Now let's start the second section of this unit, which is oncology. Why gathering cancer and genetic diseases in the same unit? Because both of them have one thing in common. They can result, or they do result, from genetic abnormalities. They do result from genetic mutations. So the big question is, what causes cancer? What causes cancer? Is it genetics alone, or is it environment, or what? So how can you explain this picture? Yes, we know that smoking causes lung cancer, but how can you explain that some live for 90 years, 100 years, and they are smoking, yet they have no cancer, they develop no lung cancer? So it's definitely not genetics alone, maybe some effect of the environment. What could it be? Actually, the answer is both. So what causes cancer? It's a combination of genetic effects and environmental effect. And I like this picture, and I like the saying that says, if you're gonna be dumb, you'd better be tough. So if you are gonna be dumb with your life and do all the risky behaviors and eat junk food and not like working out and smoking and drinking and putting yourself in danger, you better have the good set of genes, because it's always going to be, do you have the good set of genes? Do you have the right environmental conditions? Then you're going to be kind of protected against cancer. Cancer cells. What characterizes cancer cells in contrast to normal cells? When a normal cell divides, this has to happen due to a reason, for a reason. Normal cells do not divide on their own. Normal cells divide only when they are instructed to. When they transform into malignant cells, and we call this transformation. So what's transformation? A normal cell becoming a malignant cell. And malignancy is all about cell proliferation. Cancer is abnormal cell proliferation. So cancer cells are autonomous. They divide on their own. They will decide for themselves when and how much I need to divide. They will not wait for someone to tell them it's time to divide. They have autonomy. The second character of malignant cells, immortality. Normal cells divide anywhere between 10 and 50 times in a cell life, and that's it. And this cell will either die or stop dividing and become replaced with a new cell. But malignant cells, they keep dividing endless number of times. They never stop dividing. They are immortal. You cannot kill them. They do not die by themselves. The last important character about malignant cells, anaplasia. Do the language. Ana, without, plasia, form. These cells lack differentiation. What's the meaning of differentiation? We have our cells differentiate, specialize, look like. This group of cells look like liver cells. They have become differentiated as liver cells. These group of cells become differentiated as breast cells. But malignant cells, they lack differentiation. You look at the cell and you ask yourself, where did this cell come from? It does not look like any other cell because it's lacking differentiation. And we have grades of this differentiation. So you can have low-grade malignancy. The cells are lacking differentiation, but they have not gone so far. They still carry some resemblance to the mother tissue. But when the malignancy is of high grade, now the cells have gone so far malignant that they do not look at all like the original tissue.